This morning's activity is to begin the process of changing out the lead-acid batteries on board Athena with lithium iron phosphate. The price of lithium iron phosphate batteries has come down significantly to the point where they actually are very close in price to the AGM and glass mat batteries. So I went ahead and purchased two of these 12-volt, 200 amp hour batteries with a 200 amp BMS, meaning that each battery on its own can allow for 200 amps continuously. So between the two, that would be 400 amps, although we won't need that much at all. These do have a built-in BMS to allow for that, a little bit beefier. They also make a 100 amp BMS as well, a little less beefy, but in our case we wanted to have a little extra build-out quality. The batteries themselves, I won't do a review on them. I will link in this video to the reviews that have been done, which have been excellent, and were part of the determination to purchase these batteries. I'm quite pleased with the product documentation, which comes in a neatly packed folder, and a product manual, which gives the exact specifications needed to set the charge controller and charger to the specific parameters for this battery. Now these two batteries are going to be going in parallel. Meaning that it's going to be 12 volts, and these two will be connected in parallel, giving me the ability to pull out twice as much amperage than I would be able to pull out over the same amount of time with just one battery. Before we connect these batteries up, we have to actually charge them. They come from the factory partially charged. The voltage on both of them were within 0.2 volts of each other. This one was reading at 13.2, and this one was reading at 13.18. The batteries need to be charged according to the manual and product documentation to 14.6 volts, pushing through 14.6, which will then settle back to about 13.7 after the charge cycle is completed. I've already charged up this battery, and this one is the next one on the list to charge. Once both of these batteries are charged up to 14.6 volts, you then let them rest for a period of time, and the voltage will drop back down to about 13.7. When the voltages on both of these match, which means they've both been charged and both been allowed for an hour or so to drop back down to a point where the voltages stabilize, then the two batteries are connected together in parallel and allowed to rest together so that they can equalize each other. You do that for 12 hours. After that, then the two batteries can be connected to the house load. It's important when connecting batteries in parallel, especially with lithium iron phosphate batteries, that they both be the same voltage so that we don't have a variance and that one is providing more power than the other, or one is has more drain on it than the other. We'll go over that as we set these up, and first we have to charge. We've chosen to charge the batteries with the Amperetime charger, just to keep consistency in our tests. This is a basic 10 amp model charger that will charge slowly. In fact, because these are 200 amp hour batteries, it would take 20 hours to charge a battery that's completely empty. Since these batteries are already 70% full, based upon the voltage that they're at, it will take about 8 hours to charge, which is fine. So what we will do is charge up this battery to 14.6. I'm going to just double check the reading on here. And we're at 13.19 volts. We'll let this charge, and when it becomes steady green on LED number 2, we'll know that we're at 14.6 volts. We'll disconnect and test the voltages and move forward from there. We'll see you in a little bit.
2 hours later.
We've finished charging our batteries, and checking the voltage between the batteries, we find that there's a slight difference. And before I connect them up to pair them, I want to make sure that the voltages are as close to being the same as possible. Let's take a look at the voltages. Okay, we've got one 13.57, and our other battery is 13.64. This light's been used to bring down the voltage a little bit on the batteries. It's only 2 watts, but it's actually been enough over the course of some time to bring it down to within about 0.1 volts of each other. So what we do next at this point is connect the 2 batteries in parallel and allow them to equalize each other over about 12 hours is what's recommended. So we'll do that, connect them up, and that should bring the voltages a little bit closer to being the same between the 2. And then at that point, once they're equivalent, we'll move them into the hole where the battery box is and power up our house with them. At this point, we have both batteries connected in parallel, plus to plus, minus to minus, so that the 2 batteries can equalize each other. We'll let them rest for 12 hours, and then we'll check the voltages on each battery. Disconnect and check the voltages on each battery and the voltages together. So we're taking out the old batteries and we're replacing them with the new ones. The old ones are in the hallway, and Gary and I are going to lift them out. Maybe. Lift it. I'm going to come over and grab it. Oh my god. Good. Oh my god. Wow.
One.
These are heavy.
These are heavy beasts.
These are much lighter.
Wow.
Wow.
Smaller.
Voltage looks good. 13.5 volts. We have power. We're going to use the Victron Energy configuration tool, which is available from Victron. It will say when it pops up that it should be used by qualified personnel only. Consider yourself qualified if you are working with lithium-ion batteries, since lithium-ion batteries require specific modifications by the user. Once the tool comes up and you've accepted the disclaimer, go ahead and search after you've plugged into your Ethernet port. Do an auto detect for the device. It'll look across all COM ports and determine which COM port the device is located on, at which point it will start to download all of the configuration data from the Multiplus onto the GUI. This graphics user interface is relatively simple to use. Once it comes up, we'll have all of our configuration files from the Multiplus, and we'll go ahead now that it's actually come up and bring that to. Okay, now that this is up, we will move over to the charger section. On the charger tab, you can specify the battery type here, lithium ion phosphate. Click OK. Change any of the parameters you want on here, and after you've made changes, you can go ahead and send those settings, modified settings, to the Multiplus unit. You can monitor all of your Multiplus configurations with the VE bus monitor here, which shows the DC out and the current line 1 on the mains coming in. Right now we're showing that the batteries are full at 14.4 volts and we are configured appropriately. One other piece you'll need to configure is using your phone. You can connect to your Victron chargers, and in this case we have a charger configured named Athena 1. We'll actually have a second one at some point, but for now we have 400 watts coming in, maximum potential, and it's a cloudy day so we're only getting 16. Click on the asterisk for the cogwheel for the settings and change to battery. Select battery. On battery you can go ahead and specify the type of battery that you are utilizing, maximum charge current, and you can specify the presets. In this case there are specifics. I've specifically defined my settings. There are just settings in the settings here. The predefines include lithium ion phosphate. I'm not choosing that because I'm actually specifying values that are pertinent to this particular battery. So right now our absorption voltage is set for 14.4 and 13.8 for the float voltage as required by Amperetime. And that is it. We are now configured.
For more awesome content, like and subscribe now.